In this video, I'm going to cover the distance formula and the midpoint formula. If you want to find the distance between 2 points, all you have to do is use this formula here. Now, when you're given 2 points, it doesn't matter which one you consider point 1 and which one you consider point 2. The thing that matters is if you put the 1, if you put that first here, then the 5 that comes along with it needs to be first in the second set of parentheses. So, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I will use these to be the first values, and then the other ones will be the second values. So d is equal to, so x1 I'm going to make 1, and then minus 4 squared plus 5 minus 7 squared. So d is equal to negative 3 squared plus negative 2 squared. So that is equal to the square root of 9 plus 4, or the square root of 13. Now, it does not matter which order you put these points. In this case, it would have probably been easier if I had used the 4 and the 7 as the values that appeared first, because then I wouldn't have had to worry about these negative values here. But it does not matter. Okay, so now let's do the next one. I'm not going to rewrite the formula, I'm just going to plug it in. So I will let these be my first values. So I'm going to do the square root of 18 minus the square root of 8 squared plus the square root of 27 minus the square root of 12 squared. Now, because I have these square roots here, currently the way they are, I cannot add or subtract them. I need to first simplify them to make sure that they could be combined. So d is equal to the square root of 18. 18 has a perfect square factor of 9, so the square root of 18 will simplify to the square root of 9 times 2. 8 has a perfect square factor of 4, so that will simplify to the square root of 4 times 2. And now with 27, 27 has a perfect square factor of 9, so it's 9 times 3. And square root of 12 has a perfect square factor of 4, so 4 times 3. Okay, so d is equal to. So once you have these set up, you can go ahead and simplify them. So the square root of 9 is 3, so this will simplify to 3 square root of 2 minus 2 square root of 2, because the square root of 4 is 2, and then squared, plus this can be 3, because the square root of 9 is 3, so 3 square root of 3, minus, and the square root of 4 is 2, so 2 square root of 3, and squared. Now, since these have the same radicand, they have like radicals, excuse me, we can go ahead and simplify them by combining them. So the square root of this 3 square root of 2's minus 2 square root of 2's would be 1 square root of 2. Then I need to square it. 3 square root of 3's minus 2 square root of 3's is just 1 square root of 3. Then square it. So, let's do it over here because I'm running out of room. The square root of 2 squared is just 2. The square root of 3 squared is just 3. And 2 plus 3 is 5. So my distance is the square root of 5. Okay, last one. So I'm going to do d is equal to the square root. So I'll do pi minus pi over 2 squared plus 0 minus 1 squared. Pi minus pi over 2 is simply pi over 2. 0 minus 1 is negative 1. When you have a fraction like this being squared, you got to square both the numerator and the denominator. So we have pi squared over 4. And then negative 1 squared is just 1. Now, depending on what you're doing, this might not, you probably won't want to leave it in this form because it's not really simplified. So what I want to do is add these two fractions here. So I have pi squared over 4 plus 1. So I'm going to rewrite 1, or I'm going to use 1 as if it's the fraction 4 over 4. So that I can easily add them. Now they have the same denominator. So this is pi squared plus 4 over, over 4. And the reason I did that was because I knew that when I use the property that allows me to take the numerator and denominator of a fraction inside a radicand and take the square root of both of them, the numerator and denominator separately, I would be able to get this square root of 4, which would then allow me to simplify that. So this part on the top, it can't simplify. We're going to leave it the way it is, but the square root of 4 is 2. So this would be your final simplified answer. The midpoint formula says essentially you can find the x value by finding the average of the two x values, and you can find the y value by finding the average of the two y values. So if I want to find the midpoint between these two, all I need to do is 1 plus 4 divided by 2, and then 5 plus 7 divided by 2. So 1 plus 4 is 5, so 5 over 2, and then 12 over 2, which simplifies to 5 halves and 6. So with number 2, we're going to do the same thing. So I'm going to do the square root of 18 plus the square root of 8 divided by 2, the square root of 27 plus the square root of 12 divided by 2. Now we simplified these earlier. The square root of 18 we found to be 3 times the square root of 2, and the square root of 8 we found to be 2 times the square root of 2. And the square root of 27 we found to be 3 times the square root of 3, and the square root of 12 is 2 times the square root of 3. So, let me continue it down here. So that's 5 times the square root of 2 divided by 2, and that won't simplify any further. And then 5 times the square root of 3 divided by 2, which will not simplify any further. Okay? The thing that makes this last one tricky are the fractions that you're going to get. So you just have to be very careful with it. So if I start with this, I'm going to do pi minus or plus pi over 3. So pi plus pi over 3, all divided by 2. And then 1 plus pi over 2, all over 2. Now I'm going to go ahead and write out the work for the fractions for this. If I want to combine these two fractions, they both have to have a denominator of 3. So I would need to rewrite pi as 3 pi over 3. And for this one, I would need to rewrite 1 as a fraction with a denominator of 2, so it would be 2 over 2 plus pi over 2, whole thing over 2. Okay, so now that these have the same denominator, I can easily combine them. So it's going to have a denominator of 3, and the numerator is going to be 3 pi plus pi, which is 4 pi. So 4 pi over 3. And then we don't want to forget that the whole thing is over 2. So you might want to put this in parentheses just to make it easier to look at. And so now I have 2 plus pi as my denominator here. So 2 plus pi all over 2. then the whole thing is over 2. Okay? So with this, whenever you have a fraction being divided by a whole number, what you want to do is take this fraction and multiply it by the reciprocal of that whole number. So I'm going to do 4 pi over 3, and it needs to be multiplied by 1/2. And then here I have 2 plus pi over 2 times 1/2. So this one's a little easier to simplify because it's just multiplication. This will cancel out with that, leaving me with just a 2. So this will be 2 pi over 3. This one's a little more complicated because when I perform this multiplication, I'm going to have 2 plus pi over 4. Now, that is not simplified because this 2 and this 4 have factors in common. So what I need to do is kind of unsimplify it again by doing 2 over 4 plus pi over 4. So I get 2 pi over 3, and this is 1/2 plus pi over 4.